Welcome to another example of integration by substitution. Looking at our integral, notice how we have a composite function, which means normally we let u equal the inner function, or in this case, the inner function would be x minus 4. So if we let u equal the quantity x minus 4, notice using this equation, our denominator would now just be u to the fifth. But once we identify u, we need to find differential u, so we can write the integral in terms of u. So differential u is equal to the derivative of x minus 4 with respect to x times dx. Well, the derivative of x minus 4 would just be 1, and then times dx, so differential u is equal to dx. So now using this equation, we could perform a substitution for dx. So now we're going to write this in terms of u. Let's go ahead and factor out the 2. And we'll have the integral of, if we factor out the 2, the numerator is 1. The denominator is now u to the fifth. And remember, dx is equal to du. So before we apply the power rule of integration here, we're going to change the form by moving this up to the numerator, which will change the sign of the exponent. So now we have 2 times the integral of u to the negative 5 differential u. Now we'll integrate. 2 times u to the negative 5 plus 1 is negative 4, divided by negative 4 plus c. Well, the 2 and the negative 4 simplify. That changed to a 1. This changes to a 2. So the coefficient would be negative 1/2. So we have negative 1/2. Remember, u is equal to the quantity x minus 4 to the negative 4th plus c. Let's go ahead and write this as a fraction, though. This would be negative 1 divided by 2 times the quantity x minus 4 to the 4th plus c. And if we move the quantity x minus 4 down to the denominator, the exponent of negative 4 changes to positive 4. This would be our antiderivative function using u-substitution. I hope you found this helpful.